Chapter 1.6, Adding and Subtracting Rational Numbers. So, thinking about distance on a number line, the distance between two numbers on a number line is the absolute value of their difference. So, absolute value of their difference. Okay, we'll come back to that in a minute. What I'd like you to remember is the rules from lesson 1.2 about signs alike when adding versus signs unlike when adding. Okay, if you don't remember them, go back and look at lesson 1.2 really fast so that you can clarify. So, example 1, same sign. The sum of two positive rational numbers is positive. The sum of two negative rational numbers is negative. This goes under the signs alike category. So let's take a stab at these. Problem A. I have 1 3/4. That's 4, really bad one. Plus 2 1/8. Well, I can't add fourths and eighths, so I need to change this into a common denominator. So I'm going to multiply by 2 over 2 and get 1 6/8 plus 2 1/8. 6/8 plus 1/8 is 7/8, and 1 plus 2 is 3. So the answer to A is 3 7/8. Positive because both addends are positive. In B, we have negative 3.5 plus negative 4.25. Now, do not forget, when you are adding decimals, you have to line up your places and line up the decimals. So, ones place, decimal, tenths place, etc. So, I'm going to go ahead and add the 0 here just for fun. Because remember, adding a 0 does not change the value. So 0 plus 5 is 5. 5 plus 2 is 7. 3 plus 4 is also 7. And both of these numbers are negative. So my entire answer will be negative. So negative 3.5 plus negative 4.25 is negative 7.75. Now notice with both of these, I turned the problems vertically. I would like you to do the same, please. All right, different sign. Find the absolute value of each addend. Subtract the lesser from the greater. The sum has the same sign of the addend with the greater absolute value. I'm going to give myself a little bit more room and move these up here. Okay, so problem C. 1 3/4 plus negative 2 1/8. So my signs are unlike, so I'm actually going to subtract and keep the sign with the number of the greater absolute value, which in this case is negative. So I'm actually going to have negative 2 1/8. Just kidding. Let me start that again. Rewind. So I'm going to have 2 1/8 minus 1 3/4. Well, again, I have to have a common denominator. So multiply by 2 over 2, and I get 1 6/8. Bring my 2 1/8 over, and now I subtract. However, I cannot do 1/8 minus 6/8. I don't have enough. So I need to borrow 8/8 from my whole. So instead of 1/8, I now have a total of 9 because I borrowed 8/8 or a whole. So 9/8 minus 6/8 is 2/8, and 1 minus 1 is 1. Well, 2/8 reduces to 1/4. So 2 1/8 minus 1 3/4 is 1/4. However, the negative 2 1/8 has the greater absolute value, so my answer is negative 1 1/4. Same process here with the decimal. 4.25 has the greater absolute value. So 4.25 minus 3.5. I'm going to throw in the 0 there as well. 5 minus 0 is 5. Can't do 2 minus 7, so I'm going to go borrow. 12 minus 5 is 7. Decimal. 3 minus 3 is 0. Now, the 3.5 is negative. It actually has the smaller absolute value. 4.25 has the larger absolute value. So my answer is going to stay positive. All right, I know that was a lot, but let's take a look at example 2. To subtract a rational number, we're going to add its opposite. So I'm going to start 6 2/3. It's a 2. Really it is. Minus negative 3 1/3. So way back in lesson 1.2, we also talked about adding the opposite. So I'm going to change the subtraction to addition, and the opposite of negative 3 1/3 is positive 3 1/3. So I'm going to rewrite my problem now, and I'm going to rewrite it vertically. So I have 6 2/3, but now I have plus 3 1/3. Well, 2/3 plus 1/3 is 3/3, and 6 plus 3 is 9. Well, 3/3 is the same as 1, so that's equivalent to 10. Same thing. Negative 4.68 minus negative 5.79. So I'm going to change this to adding the opposite. Notice I'm changing both. I have to change it to adding the opposite. So now I have negative 4.68 plus 5.79. Now I have a negative and a positive. My signs are unlike. So the 5.79 has the greater absolute value. So 5.79 minus 4.68. 9 minus 8 is 1, 7 minus 6 is 1, and 5 minus 4 is also 1. The greater absolute value is positive, so my entire answer is positive. Okay, last one, example 3. You can subtract rational numbers to find temperature differences. So the temperature was 3.5 degrees Celsius at noon and negative 2.7 degrees Celsius at 6. So find the change in temperatures. So my start minus my end will equal the change. So I started at 3.5 degrees minus my end, which was negative 2.7 degrees. I'm going to change this to adding the opposite because I don't subtract anymore. And now I have two positives. 3.5 plus 2.7. Oh, random color change there. 5 plus 7 is 12. 1, 2, 6. So my temperature change was 6.2 degrees Celsius. Now, does this make sense? So a temperature change, okay, it's kind of like a distance. A change cannot be negative. I can move forwards and I can move backwards, but the distance that I'm traveling is still positive. If I was to think about this on a number line, so if this is -3 degrees, -2, -1, 0, 1, 2, 3, 4. So I started here at 3.5 degrees, and I ended down here at 2.7 degrees. How far is it from here to here? How many degrees is that? Well, I know I have 3.5 degrees from 3.5 to 0, and I have 2.7 degrees from -2.7 to 0. So that total distance, I'm going to actually add those together, which is why adding the opposite is so perfect. And yes, the total distance is in fact 6.2 degrees. Okay, that's it for examples on this lesson. Please complete your QCs and CYUs, and I will talk to you soon.